this country. Okay, so let me start. So I'm putting some libraries, pandas as PD, numpy as NP, and then import sklearn because that will be needed for the machine learning. And let me import matplotlib as well. Import matplotlib dot pyplot as PLT. Okay, done. And let me read very simple data set for you so that you can understand the process, what actually how linear regression basically works. So I'm coming here and reading one data set EF is equal to PD dot read underscore CSV. Okay, and I think I have a data set known as salary. Come on, yeah, salary dot CSV. Let me read it. Okay, very simple it is, but I want to show you actually. So df dot head. Okay, so only two columns are given here: year of experience and the salary. Intentionally I took such so like you can relate, you can see the graphically, because if you are having a multiple columns, it will be very much difficult for visualization purpose. Okay, so at least you can understand the core concept, then you can implement it anywhere. Core concept always remains same. Okay, so we have year of experience is given and salary is given. What is our task? Our task is to predict the salary if somebody gives me the corresponding year of experience. Okay, so if somebody shares me the give me the year of experience, I have to predict how much salary he will be having. So this is my input variable, this is my output variable which is available. Let me check the shape of the same, how many rows and columns are there. So we have just 30 rows and 2 columns. Okay, one is output column, one is your input column. Fine, no issue. Let me check the missing values. Df dot is null method and then dot sum. Okay, so no missing values, perfect. So let me just explore the data. Okay, let me separate X and Y. Okay, so X is my years of experience, Y is my salary. So you can directly mention that X is equal to, so we have only one column, so no need of doing the dropping or something. I can directly, or I can use, if I my choice. So I can mention df dot drop. Okay, what is my column name? Salary, because salary. Okay, and X is equal to 1. And then my Y should be what? Y should be nothing but df and double bracket salary. Execute done and let me verify once. X is X dot head, only one column, perfect. And let me check Y dot head. Okay, only one column, perfect. And let me try to plot. Okay, let me check the relationship. What kind of relationship we are having? See, so we have a numeric data at both the end. Okay, salary is a numeric column, head is a numeric column. So to see the relationship between numeric columns, we can go with a scatter plot. Okay, so I am just mentioning here PLT dot scatter. Okay, and I can directly pass X comma Y. Okay, if you see here, we can see some kind of is here in x-axis we have your salary of year of experience available. On the y-axis we have a salary available, and some kind of linear relationship we can see. Can you see everyone? Please notice. Is it somehow linear or not? Means when your this is increasing, your salary is also increasing, right? Right. So we have to do that.
Yes, sir.
So okay. So same thing we have to do. So let me do one thing. Let me just split my data. So I'm going to say from sklearn dot model selection. Okay, import train test split. Perfect. Okay, and from this let me split my data. So first of all, it will give me four outputs. So x train, x test, y train, y test. Okay, equals to train test split, and within that I can pass my x comma y, and then my test size is 0.2, and my random state is, let's say, 42. Okay, done. Awesome. Okay, and now it's been done. Now do one thing. Remember, linear regression is a distance-based algorithm. So distance matters a lot. So whenever you have a distance-based algorithm, what you should use, everyone? Scaling.
Scaling.
Right? Scaling we have to do, right? So from sklearn dot pre-processing, import standard. You don't have to memorize. Just but moment you type now, just press tab. Automatically it will give you the hint. Don't need to memorize so much thing. Standard scalar, and it's a class. So let me create an object of the same. So I'm saying s is equal to standard scalar. Okay, so object has been created. From that object, what we will do, we will uh, fit, we will transform and fit, okay, on the training data, and we will do only transformation on the test data. Okay, that we know, we have already done that. So I'm going to mention x underscore train, suppose scaled, equals to s dot fit underscore transform of which data, x train data. From this, because we are using standard scaling, what it will learn, it will learn the mean value and the standard deviation from the training data. Okay, and now x underscore test underscore s equals to s dot transform. So test only transform on the test data, x underscore test. Okay, let me execute. Everything done, awesome. Now I have to build my model. So very simple. I will just mention from sklearn dot linear model this time. Okay, this thing only you have to remember which model is available in which library, right? So sklearn dot linear model, import a class known as linear regression. This is what we want. Okay, let me come here, create an instance of the same. So model equal to linear regression. Okay, it has few parameters that we will discuss that, don't worry. Okay, linear regression. And then once it is created, I have to fit my model, train my model. So model dot fit on x underscore train underscore s and y train, right? So I just mentioned here y underscore train. Okay, so my model has been trained. Okay, and now this model has various parameters. Remember, what is the equation of straight line? Y is equal to mx plus c and something. So if I go here and put model dot, okay, example coefficient. Okay, so you want coefficient, you want parameters, different things are there which you can get it here. Okay, these methods are available here, but they are not visible, no issue. Let me come here, model dot, for example, we want different parameters. Example, intercept. What is the intercept? Execute. So this is the intercept, right? Which is available here. So different, the equation of line is there. You know what is the intercept? Y is equal to mx plus c. So c is what? Your intercept. You want to get the coefficient. So yes, you can get the coefficient. Model dot coefficient. Okay, it will give you the coefficient, corresponding coefficient which is available. Okay, so from this you can understand what straight line it is guessing. No problem. Now come here, and now let's try to predict my y test from the x test. So how will I do that? My model has been trained. So from the same model, I will predict the value of y test. So I'm going to say that model dot predict. Which value I want to predict? I want to predict the value of y test from where? From the x test underscore again s, and I want to call it as suppose y pred. Done. Let me come here. So my y pred is damn ready. Perfect. Very good, right? It has been done. Now let me check the matrices as well. So let me come here. So from sklearn dot matrices import. Suppose I'm importing mean squared error. Okay, I'm importing. I think I've used this R2 score or not earlier. Anyone remember I've discussed this R2 score or not?
Sorry, sir. What square? R2 square?
R2 score. I know if you don't remember
No,
that means
sir.
no issue. No,
We
if I've not,
don't.
yeah, perfect. Okay. I think mean squared error we have seen that, right?
Yes, sir. Mean square, root
Mean
mean square error, and
and mean absolute error.
mean absolute. Yes.
Actually, there is one more matrix known as R2 square. I'll tell you that in few minutes. Okay. So let me compute mean squared error. It needs two value y true and y pred. Every argument needs y true. What is y true? Means actual value of actual values of your y test. What is that? Y test. Okay. And predicted values are what? Y pred. Okay. So it will give me some mean squared value. Fine. Similarly, R2 score. So R2 underscore. I also need two parameter y true and y pred. So y, see, every matrix needs same thing, y true and y pred. So I just mention y test once again. This is my true value and this is my predicted value. Okay. So I'm getting 0.92. Now come, what is this R2 score is all about? Okay, let's come here. What is this R2 score is all about? Okay. So if I come here to and select a pen. Come on. Why it is not coming? Yeah. Pen. Yeah, perfect. See. Suppose this is your x and this is your y, corresponding y value, or this is output and this is corresponding input value. Okay, and some data points are given to you like this, like this, like this, like this, like this. Okay, so first of all, understand what is the R2 score. So R2 score basically means, okay, 1 minus, everyone see properly, okay, SS residual upon SS total. This is the formula of your R2 score. R2 score is what? 1 minus SS residual upon SS total. What is SS means? SS means sum of square. Sum of square. Now, what is this? This is sum of square total. This sum of square residual. What do you mean by that? Let me tell you that. Suppose what you will do, you will first of all compute what machine learning model internally will do to compute the R2 score. It will compute SS total. And how it computes SS total? Okay, so this x is given and these are corresponding y values are given. Okay, this is corresponding y value, this is corresponding y value, this is corresponding y, this is corresponding y, this is corresponding y. So what it will do, it will find the average of the y. So suppose y is having a 5, 6, 5 again, 2, 3. So suppose these are all y value and corresponding x values are suppose 1, 2, 3, 4, 5, something like that. So what it will do, whatever your y column is having, it will find the average value of the same. It will find the average value of the same. So what will be the average value example? The average value will be, of course, a constant value. Okay, will be a constant value. So suppose that constant value is here. This is your constant value. So you put a line here. That constant line. This line is what? An average line. Okay. This is your average line. So first, what we'll do, understand everyone, we'll compute the SS total. And how SS total is computed? Whatever your Y column is, from that Y column, it will compute the average of the Y column. And whatever average value is coming, suppose 23 or something, whatever is coming, you will put a constant line there. Now, what you will do, you will compute the distance of every point. So actually understand what it's saying. This is the predicted line. Example, but what kind of predicted line? Average line. Okay, this is the average line. From this, actually, we'll compare our performance. This is the average line. And from this line, we'll compute the line, we'll compute our model, which has been predicted by my machine learning model. So this is the average line. From that average line, actually compute the distance of every point. So this distance, okay, this distance, this distance, this distance, this distance. Okay, sorry, not this distance, perpendicular. It's coming right like this. Perpendicular distance. I compute this distance compute. Okay, now this distance will be what? Suppose this point is first point. So I'll mention this. Suppose this is my average line. Okay, and these are my actual lines. So first point is suppose y1. So I will mention y1 actual value. This is minus this average line. Suppose y average. Y average. So I'll compute a distance. Okay, and do what? Square of this. Again sum. Second value is this. So compute this distance with this distance. What is what? Y2 minus y average square plus this distance with the this distance, that is y3 minus y average square plus this distance minus this minus this, that is your y4 minus y average square. Okay, plus last is what? Y5 minus y average square. Okay, so this is what? Sum. In between what we are doing, sum, and sum of doing which? We are doing the sum of square values. We are doing the sum of square values. This is nothing but your SS total. First of all, clear everyone, what is SS total? Please tell me. First
Yes,
of
sir.
all, okay, we'll compute the whatever y column is there. We'll come find the average of that, and that we'll draw a line with that average line, and we'll compute the distance of every point from that particular point. Okay, and we'll compute the sum of square total. Now we'll compute sum of square residual. SS residual. Very much similar. But suppose what happened? Now my model predicted a line. On the basis of the data set, my model predicted a line. Suppose that line is, change the color so that you can understand them better. Let's put this line. Okay. Your model predicted a line. Suppose that line is coming like this. This is my model line predicted by model. Understand? Line predicted by my model. This is the average line. Okay. This is the line predicted by my machine learning model. Means we have trained that model, and this is the line that has been predicted by machine learning model. Okay, now what will happen? Same process we will repeat, but now distance will be calculated between this line and these points, like this. Between this and this, between this and this, between this and this, between this and this, and between this and this. This we will compute. Okay. So suppose what? Same thing we will mention now this time. Actual point is y1 and predicted corresponding value is y pred 1. Okay. So distance, this is known as your residual. Understand? This is known as error or residual. So we are doing square of the same. Okay. Plus y2 minus y pred 2 square plus y3 minus y pred 3 square. What is these points, everyone? This is first point, your y1. Okay, this is your predicted value. So y1 minus predicted value, distance of this point with this point. So this is suppose y pred. Okay, so this one minus this y pred. Okay, square. Second point is this point. So this is your actual value. This is your y2 minus predicted value is what? This particular value. So y this minus this whole square. Third point is what? Example, this point. So this point is your y3 minus predicted value is this point. So this is minus y square plus. Okay. Y4 is this. Distance of this with this is this. So this is the predicted value. So predicted value is what? Y4 minus y pred 4 whole square. Okay. Plus y5 minus y pred 5 whole square. Right. So this is nothing but these are what? Residual. Individual values are known as what? Residuals. What you have done of them? You have done the square of those. Okay. And what you are doing now? Sum of squares of residuals. Sum of squares of residual. These are what? Squares of residual. This is S res, means squares of residuals. Means your distance between your original data point and predicted data point. Because why I'm saying predicted data point? Suppose this is my machine learning model. If I give the same point, the corresponding value y. So actual value is this value. Okay, actual value is this, but as per my machine learning model, I will say, okay, project this point on the line, and this will be your predicted value of y. That's what I'm saying. This is the predicted value. Similarly, actual, we move x is here, so corresponding actual value is this point. But as per my machine learning model, will say, okay, project this point on the line, wherever it is meeting, that will be corresponding your y value. That's what I was saying. These are predicted values. So this is what your individual, these distance, this difference is known as residuals. We have done the square of those, squares of residuals, and what we are doing? Sum of these. So that's why it is known as sum of squares of residual. Clear, everyone?
Yes, sir.
Okay, 2 points should be clear. What is SS residual and what is SS total? Now, what is your R2 score? R2 score is, let me clear everything now if it is okay. Let it be. Okay. So suppose what is the distance? 1 minus SS residual upon SS total. So actually, your model will be compared with the average model. Understand, everyone? So ideal value should be what, everyone? Ideal value of R2 score, as per you, can you guess what should be the ideal value of R2 score? As per the understanding.
As close as to 0.
No. See properly. I'm talking about R2 score. As per you, tell me which of the parameters should be 0. Of course, my model prediction should be perfect, 100% perfect, ideal or not. Tell me everything. Ideally, it should be perfect, no?
Yes.
Right? In
Yes,
that
so
case,
it should be 1. It should be 1.
yes. In ideal case, the distance between your actual point and the predicted line should be what? 0. Right or wrong? Actual and prediction should be same. When actual and prediction should be same, then this difference will be what? 0, 0, 0, 0, and 0. Right or wrong? Right? When actual and prediction is same, that means what? Your every point, your actual point is every actual point is lying on the same line which has been predicted by my model. Okay, actual every point is lying on the same. Right? That is my actual model. Right? That means this sum of residual means error is 0. When error is 0, this SS residual will be what? 0. So 1 minus 0 upon something will be what, everyone? 1. So this is the perfect value. Right? Clear?
Clear, sir.
Right? But suppose, what is the worst model? What is the worst model? Worst model is when your SS residual is greater than SS total. Means this is the random model we have taken. But not random, we find the average line. Your model, when SS residual, okay, is greater than SS total. Understand, when this value is greater than this, means what is happening? Your model is performing so bad, even is better than the average line. It is even better than your third class model if you are having. It is a third class model, means I've just put an average line, and from your model is even performing worse than the average line. When that will be the case, actually, what will happen? Remember, this value will be when greater than the SS total. In that case, what will happen? This value will be greater than 1. And 1 minus some value greater than 1 will be what? Negative value. So whenever you get R2 score to be negative, understand your model is a third class model. Don't use it. Okay. So ideally, what should happen? This term should be as small as possible. Okay. This term should be as small as possible. When this will be as small as possible, of course, very small quantity divided by this will not make any difference. It will be a small quantity only, right? Very small, because this should be as small as possible. When it will be as small as possible, then it will be very much closer to 1. So ideal value should be 1. Ideal value of R2 score should be 1. If not 1, at least close to 1 as much as possible. Clear, everyone? What is R2 score?
Sir, that is clear. But
Mm-hmm.
is it compulsory that we must take average line on y-axis?
Actually, it will automatically come. We are not doing this. We will not do this. This will automatically internally tell by computation. This is our
Okay.
output. Output, how normally we put where. Doesn't matter where you put it. It barely matters. The process will be same. Getting my point? Doesn't matter you put
Yes.
on the y-axis or x-axis. Process will be same.
Okay.
Uh,
And sir, this is we have done for when we have 2D data. But
uh-huh.
if we are working with 3D point cloud data or something
Again,
like
again,
that.
again, process will be same. Again, I see. We cannot visualize that thing, but the process will remain always the same. Okay, you will find the average model, the model based on the average line, and you will compute the performance with your actual model with the performance line. Actually, that cannot be visualized. That is the main issue here. Okay, so
Yes.
that's why that's why the process actually will remain the same process. Okay, you will be compared with the average model. Your performance will be compared with the average model only all the time in the R2 score. Got it? Actually, we cannot visually visualize that. That's the main issue. But I hope you
Yes.
get the concept. Okay, that what is going to
Yes.
happen.
Right.
Okay, yeah. So let me clear this out. Okay, so whenever some machine learning task is given to you, at least derive 3 to 4 matrices. Okay, like mean absolute error, mean squared error, root mean squared error, and R2 score. These are good matrices. Okay, that you can do, and we are getting a decent average. Can you see 0.90? It's decent. It's not bad. Okay, and now we can see also. Suppose I do one thing. Let me come here and let me try to plot one thing. PLT dot scatter once again. PLT dot scatter between x and y, and this time I'm taking x train example, and I'm taking suppose y train. Okay, and or x train, whatever x train scaled we have taken now, x train scaled, and y train, and suppose color I'm picking to be red, let's say. Okay, and on the same visual I want to plot one more plot, a line plot, so that we can see my model is predicting line or not. So VLT dot plot. Okay, and here I'm passing my, again suppose x underscore train underscore s, and I'm passing my model dot predict. I want to predict the value of y train because we have predicted the value of y test from the x test. Okay, so I'm just checking on the training data first of all. Model dot predict, sorry, model dot predict, and here let me pass my x underscore train underscore s, x underscore train underscore s, and let me make the color to be let's say COLOR is equal to blue. Okay, let's check what kind of graph we are getting. Can you see everyone? It is predicting very good. Can you see? These are your actual points. Okay, and this is the line that your model is predicting. Right? Suppose I just comment this and execute this. See, this is my actual scatter plot between y train and x train. Right, between y train and x train. Okay, and when I do this, what is the predicted value? So here I'm plotting x train versus predicted value. Okay, this is your actual value that you are seeing right now. I want to see x versus predicted value, so I just execute this. So I'm getting predicted value. It's a linear regression. It is finding a line only. Can you see everyone? Please tell me.
Yes, sir.
Right, similarly what we can do, see visualize same data on the test data as well. This is a training data which we are seeing, right? Let me check, suppose x underscore test underscore s. Okay, and here your y test. And here also I am doing x test underscore s. And here I'm passing x test underscore s. Same thing, this time on the test data. It's fine. This is decent enough. Decent enough. Okay. And don't build a model which is like this. If it is like this, reject it, everyone. Suppose you saw in a training data, okay, you have a training data and you find a model like this. This means which is predicting every point of view. You may say, sir, this is the best. But actually, what is this? Understand, it will learn, it is learning too much. That is the main problem. It is learning too much. If you are getting such kind of graph, means which is passing through every point, understand everyone, this is your overfitting. You have learned everything in the training data. That's what I'm saying. I'm talking about training data specifically. When I'm referencing that, I'm not talking about test data. Test data is at the bottom, right? It is able to, if it is doing that kind of curve on the test data, awesome, very good. Because test data is unseen. On the unseen data, it is giving very good model. That is very good. But if it is in the training data, it is giving that kind of model, means it is learning every point. Every point it is learning, then its side model is not acceptable. Actually, it will be overfit. So when you will give some unseen data, it will not perform well. Okay, so don't get this kind of data. That is fine. Clear, everyone? Please tell me.
Yes, sir.
Right? Remember that, especially on the training data. Let me move ahead again. Okay, quickly, and let me bring one more data set for you. And suppose this is your df1 equals to pd dot read underscore csv, and file name is, if I'm correct, position. Yeah, fine. Execute this. Okay, and df1 dot head. It's a very small data, but actually for explanation purpose, it's very good. I think I can even remove this df1 dot head. Okay, this is the data which is available to you right now. Okay, so we have given some, only 10 rows are there: position, level, and salary. So position is given of different employees: business analyst, junior consultant, senior consultant, manager, country manager, region manager, partner, senior partner, C level, and CEO. And the corresponding level is given. Okay, the higher is the level, more higher at the hierarchy is. Okay, so same information actually is available in the level column, what is here, because ultimately, because if we are going to work, so we have to convert the text column into the numeric column. Okay, but here we have a hierarchy available. CEO is the top level, then C level, then senior partner, then regional manager, then country manager, then senior consultant, then junior consultant, then business analyst. So hierarchy is there. So when we will assign them, convert them into the numeric column. So of course they have a hierarchy. So we'll give the highest weightage to CEO. Okay, then to C level, then senior partner, and lowest level, lowest numeric weightage to business analyst. Already that has been given in the level column. Okay, so no point of taking the business column. We can drop that column. Okay, we can drop this column. It is not mandatory. So what I can say simply this: df1 dot drop. What is my column name? Position column. It's no longer required. Okay, because same information is communicated by the label also. So access equals to 1, and in place, in place equals to true. Done. Come on. Oh, sorry, df1. Sorry, df1 dot drop. Done, and let me check df once again. Oh, df1. Fine. Only one column are there. Okay, and now let me do one thing. Let me separate these, and we can see there is no missing value at all. Okay, but you will understand them here, a very important concept. That's what I tell you, small data. From a small data, if you understand the concept, automatically you can apply them on a large data without any problem. Okay, so what I'm going to mention here, suppose x1, or let me separate x1 is equal to, directly let me pick df1. I'm not using drop method. If I can use that, that's not a problem. I can just mention my x1 is my level. Okay, and my y1 is my df1 again, square bracket. This one is your salary. Okay, execute this. Done. So they have been separated. Let me verify. X1, Y1. Done. Perfect. Now see everyone. If we try to plot the relationship between them, let's see what kind of graph we will get. PLT dot scatter X1, comma Y1. Okay. So can it be guessed by a straight line, everyone? Please see properly. Can we guess the
No,
relationship?
sir.
Right? No. It will not be able to. So what we have to use, remember, we discussed some problem, same problem. So this problem cannot be solved by this, by using this straight line equation. Which equation? This equation. Theta naught plus theta 1x. It cannot be done that. So we have to introduce the polynomials of the higher degree. For example, I introduce a polynomial to be theta 2x square, right? I told you this earlier as well. And if I make theta naught to be, suppose, whatever you want to put it, okay? And y is equal to theta naught to x square. I set it to be, suppose, 0. I set it to be 0 and set it to be 1. Okay. So what I will get, y is equal to x square. Okay. A parabolic shape. From that, we can predict this line like this. Certainly, my linear regression will not help it. Directly, linear regression will not help it in this case. Okay. So when I'm passing the parameter inside my linear regression, better pass my what? A higher degree or higher degree polynomials as well. Okay, so we need to take the help of polynomial linear regression because we are not able to achieve that. Okay, so let me just show you that I'm not doing train split here because data set is very small. I want to show you how polynomial regression can help me out in the same thing. That is the main thing. This is why my purpose is. Okay, how it is going to help me out. Okay, I can do that, but actually it's a very small data set. But intentionally, I'm not going to do that. So if I come here and clear all drawings, okay, and bring what? Suppose I'm saying that from a sklearn dot pre-processing, okay, import polynomial features. Okay, introduce polynomial features. So if I execute this, it's done. Okay, and now if this is also a class, so let me get an object of the same polynomial features, and within that actually we have a parameter known as degree. Right? Can you see everyone? Degree. Okay, and default degree is what? 2 degree. Default degree is what? 2. And read this definition. That's important. Okay, generate a new feature matrix. See everyone. Generate a new feature matrix consisting of all polynomial combinations of the features with degree less than or equal to specified degree. Okay. For example, if input sample is 2-dimensional and is of the form A and B, so it will generate the degree 2 polynomial features are 1 A, B means what? Understand what do you mean by that? See, suppose I have 2 input values. What happened here? Where it happened? Where it's gone? Come on, come on, come on. Yeah, here. Okay. So suppose what is happening is you have 2 inputs A and B and 1 output Y. Okay, and you specified here in polynomial degree 2 is equal to 2. So what it will do? It will understand. It will create all the polynomial combinations up to degree 2. Okay, so I will mention. It will mention like this: A0, B0, A0, B0 as first term. Okay, first feature I can call it as right. Second feature will be example A0, B1. Okay, third feature will be, let's say, A1, B0. Okay, and then it can be what rest. I think everything has been covered. A0, B0 will be 1. A0, B1 is fine. A1, A0 is fine. We can mention this way. A2, B0. We can mention A0, B2, right? And we can mention A1, B1. Okay. So up to degree 2. Okay. All the polynomial combination will be created up to degree 2. So we mentioned 0, 0, 0, 1, 1, 0. Okay. 1, 1. Every possible combination. What will give me? It will give me 0, 0. Okay. A to the power 0 is 1. B to the power 0 is 1. So what will we get, everyone? Only 1. A to the power 0 again is 1. B to the power 1. But we will get only B.
B.
This we will give me only B to the power 0 is 1. So what we will get?
A.
A. A to the power 2. B to the power 0. What will give me? A square.
A square.
Right. A to the power 0. B to the power 2. What will give me?
B
B
square.
square. And A to the power 1. B to the power 1. What will give me?
AB.
Maybe. Okay. So if we have multiple features available, it will create all possible combination. And you can guess if I get A, B, and C, what it will do, everyone. Every possible combination up to degree 2 of these 3, it will create. Right. Example first can be A to the power 0, B to the power 0, C to the power 0. Right. Next, it can be A to the power 0, B to the power 0, C to the power 1. Right. Then it can be example A to the power 0, B to the power 1, C to the power 0. Something like that. All possible combinations will create up to degree 2. If you mention degree is equal to 2. And accordingly, it will give you the term. So earlier, only two parameters were there, two input variables were there. Now, how many variables will be created, everyone? 1, 2, 3, 4, 5, and 6. So now they will be used to create your model. Okay, and you can, this degree is a hyperparameter, so you can change for the 2 what I will get, for the 3 I will get, for the 4 I will get, everything you can mention there. Okay, everything you can mention there. So what I am going to do here, let me come and clear all drawings. Okay, and come on, close it. Okay, let me mention a degree, although it is there, but let me, I want to show you so that whenever you revise, you can see that degree. Come on, is equal to 2. Okay, and let me give a name, suppose poly, like this. Okay, and I'm creating, suppose x underscore poly is equal to poly dot fit underscore transform. Okay, poly dot fit underscore transform, and here I can pass my x, whatever my x is. What is my x? X1, sorry, whatever my x is, x1. Okay, this is my model done. Okay, this is my polynomial feature that is having, and you can check it right now, everyone. X underscore poly. Can you see, everyone? Only one parameter is there. Now we have x1. How many parameters there in the x1? Only one. So what parameters you will get? You will get everything up to degree 2. So what will be x1 to the power 0, x1 to the power 1, x1 to the power 2, right? So what is this? 1. So 1 to the power 0 will be what, everyone? 1 to the power
1.
0 will be 1, right? 1 to the power 1 will be
1.
1. 1 to the power 2 will be 1,
1.
right? Next, to the power 0 will be 1. To the power 1 will be
1.
2.
2.
To the power 2 will be 4,
4.
right? Let me check, everyone, at the downside. Clear all right. Here, come on. Can you see, everyone? Clear? Please tell me.
Yes, sir.
Right now, what we can do, suppose I create a model of the same linear regression. Okay, and model name is model 1. Let's say model 1 equals to linear regression, and I'm gonna do fit on the same model 1 dot fit. Okay, and what is my, this time I will pass x poly. Okay, and your y1, x poly and y1. Fine. Let me execute this. Done. And now let me try to plot the graph that we were trying to see here. Okay, or I can even come here from pick from this, or let it be. We can do that. Come here. Okay, so plt dot scatter will plot x1 and y1, and let me mention color equals to red. Let me check. Fine, this is my graph, or even I can do this thing, x1 dot y1 dot poly. Perfect. Or now I can do, come here, and plt dot scatter is fine. Let me plot plt dot plot, this time x1 versus model 1 dot predict. What we pass inside x1, sorry, x underscore poly. Okay, and x underscore poly is fine. As we have passed inside, and let me make it color equals to blue. Can you check, everyone? Please check.
Yes, sir.
Right? Even if I change that, let me show you something. If I again create x1 poly, x poly we have created degree 2b2. Let me just copy this. Let me show you the power. Okay, and let me make degree is equal to 3. Okay, and let it be like this, no problem. Execute. Okay, and now let me come here again. Let me create a new model. This time model 2. Execute and fit the data. Model 2 dot fit. Okay, on x poly, yes, fine, everything is fine. Done. And now let me copy this graph. whatever it is. Okay, and model name is what? Model 2.predict, right? Can you see everyone this time? Please see the above graph and see the above graph, which is more closer to the point. Can you observe the difference in the changes? Now it is trying to predict the pattern exactly. Can you see that?
Yes, sir.
See the difference, right? Now suppose I made one more. Let me copy everything like Shift, Control C, Control V. Okay. Let me make it degree 4. Okay. Model 3. Model 3. Let me execute. Let me execute. Let me execute. And here model 3. Can you check now?
Yes, sir.
Right, it is everything learning, it is right. So more, that is the issue here. So it's not a good model. That what you are seeing right now, it's not, it's what it is doing, it is doing overfitting, right or wrong? Because higher degree polynomial you're introducing, this trying to learn from the model, trying to learn from the model. This is fine, this is fine. Actually it is not learning everything, it is not learning everything, right? So see how powerful your polynomial features can be. So some pattern which your normal linear regression is not able to predict because of its basic nature. What you can do, you can first of all take your parameters, and from that parameters you can generate your polynomial features, and from that polynomial feature you can pass inside and do the better predictions. I think it should be okay, everyone.
Yes, sir.
Okay, so anything you can apply, any data set you can take, same process will be there. Everything will be same. I just took a small data set so that you can see the relationships. You can see, analyze, okay, what is the effect of polynomial degrees? What will happen when I change the polynomial degrees, and what result we will get? Okay, how impactful it can be. So any data set can be given to you, doesn't matter. Process will be same. Everything will be same. You will take your data. Okay, after taking the data, whatever we have done so far, only difference is that you will call your regression model. What is that? Here come, sorry, regression model. This time linear regression. Okay, the model will be linear regression. You will fit on the same, and everything rest is the same. You will do the predictions if you want to do the predictions, right? And you can use the way that we have done here. Just one example, right? We do the train test split. We do the standard scaling of the data, imported linear regression, fit on the training data, find out the intercept and coefficient if you want, predicted the data, right? And find out the matrices, mean squared error if you want, R2 score method, everything else will be same. Nothing is going to be changed. Doesn't matter it's a single column or a multiple column. I think should be okay, everyone now, right?
Yes, sir.
Okay, so you can apply anything as per your requirement. Just explore, play, keep type. You will learn a lot. Okay, and trust me, whatever I am teaching, more than that, you will learn yourself when you will type yourself. Interesting ideas will come to your mind. Okay, what is possible? Let I do. Honestly, I will be honest. I 3 days ago, means on Saturday, okay, I solved one of the problem which I was thinking impossible for me. It was an industry problem, and my friend discussed with me. He's working in a good organization. So I looking at the data, I was very much clear. I will not be able to do that. Okay, by using a traditional algorithm. But trust me, at that time I write my own expression, although the code was very big, very big code it was. But when I denied to him, okay, I will not be able to do that, it was very complex actually. So pattern was very complex. I just thought, okay, let me try this thing. Okay, I explored something, and I put it expression of my own instead of relying on linear regression. It was a regression problem only, so instead of relying on linear regression, descent regression, or your KNN regressor, I just did, no, I will do myself. Let me write my own equation, okay, and let me change these parameters until I reach the this particular error. Okay, I did that, and trust me, after 6 hours, my requirement was achieved. Okay, I was damn happy. But think what I said. Okay, so when you play with it, at that time you learn. Okay, this is the possibility. Let me try this thing. This is the possibility. Let me try this thing. Always don't only rely on the things which is written in the books. Okay, you can do better than. That's how the research paper get published. If you only rely on the books, you will have to be able to achieve the research requirements. We always achieve research requirement by thinking our own self. Okay, well, if we can try this thing, what will happen? I think you are MTech student, Hardik. You may be knowing that better, right?
Yes, sir.
Yeah, this is what we do in
We
the
have to
research
do
as well.
we
Yeah.
have to do a lot of trial and error stuff.
Yes. This is how, and this is the same thing with the machine learning as well. Okay. Now let me come to another algorithm. Come on, quickly. Add new layer, add new layer, add new layer, add new layer. Okay, and quickly come to this layer. And let it be black. No problem. Let it be black. Okay. So next algorithm that we're going to discuss is how many algorithms we have discussed so far. I think 4. Okay. KNN. We started with the KNN, then we did, I think, decision naive
Naive
Bayes.
Bayes.
Then we did decision tree, and this is 4th one. Okay, logistic
Yes.
regression. Now it's a 5th. Tomorrow we'll do 3 more. Okay, 3 more. Okay, so 5th one is your logistic regression. Okay, although the name is saying it's a regression, understand everyone, it's a classification problem. Okay, algorithm. It's a binary classification algorithm. That is better. Binary classification algorithm means it can classify things into 2 classes. Okay, binary classification means only 2 classes, class 0 and class 1, like this. Only 2 classes. It can be A or B, doesn't matter. Or only 2 classes, but internally, by using some modification, it can do multi-class classification as well. Multi-class classification as well. I'll tell you that for that purpose, actually use it internally. So the core is only binary classification. Remember, the core, somebody asked you, it is a core is binary classification, but we can do multi-class classification by using the concept of one versus rest or one versus all. This concept, but we'll see that. Okay, it's very simple algorithm. Okay, and some derived version from linear regression only. See, suppose we have written an equation of a linear regression. What was that? It was very much like this: theta naught plus theta 1x plus theta 2x. Suppose theta 1 x1 plus theta 2 x2. Let this say this one, something like this. This is my equation of linear regression. Okay, so same equation can be written this way. I took a value 1, I took x1, I took x2. Okay, here x1 and x2 are my inputs. Okay, and theta naught, theta 1, theta 2 are coefficients, or we can say are the weights, corresponding weights which are available, right? And let me mention this something. I introduce here a weight known as theta naught, a multiplying factor. I introduce a weight here known as theta 1, which is a multiplying factor. I introduce a weight here known as theta 2, which is a multiplying factor. So it will give me 1 into theta naught, it will give me x1 into theta 1, it will give me x2 into theta 2. Okay. But to achieve this requirement, what we need to do, we need to sum of them. So we introduce a summer here. Like this. Okay. If we introduce this equation, so the output of this will be what? Same equation what you are seeing here, right or wrong? Right. So this equation can be
Sir,
yeah,
I'm
yes,
not
yes.
able to follow. Can you repeat, please?
See. This is the equation of your linear regression, right? This is fine.
Yes, sir.
Okay,
That
y
is
not
fine.
y is equal to theta naught plus theta 1 x1 plus theta 2 x2. Okay, and suppose somebody says represent this in terms of block diagram. Represent this equation in terms of block diagram. So we understood this way. Okay, same equation can be written like this: theta naught into 1 plus theta 1 into x1 plus theta 2 into x2. Can we write this or not, everyone?
Yes, sir.
Right. So what we did, whatever input parameters are x1, x2. Okay, we put it here. And corresponding here theta naught, what is the corresponding value available? It means analogy with the x1, means if we consider them as an input, we can consider it as 1, right? Then we introduce that there is some multiplying factors, or these factors theta naught for the 1, x1 it is theta 1, and x2 it is what? Theta 2.
Theta 2.
Okay, so if we use a summer in between, what this line will give me? This line will give me 1 into theta naught. This line will give me x1 into theta 1. This line will give me x2 into theta 2. So if we do sum of those, what I will get? I will get theta naught plus theta 1 x1 plus theta 2 x2, right or wrong?
Yes, sir.
Okay, same equation is there. Okay, but my classification task is not this. This will give me, this is why suppose my y intermediate. And this is the output that you are seeing right now is corresponding what happened here. Y intermediate, which is equivalent to this. Fine. This is output of a regression problem. Perfect. But I want classification. Okay, I want classification. So what we will do, we will convert this value, whatever y intermediate will give me. It's a regression, right? So your y intermediate can be anything. It can be a positive value. It can be a negative value or anything. We need to convert actually for classification into its probability. Okay, so what we will do, we'll convert this y intermediate value. Doesn't matter it is a positive or negative. I will convert into the value between 0 and 1, because we know that the probability always lies between 0 and 1 only. Okay, this is the logic where logistic regression comes into the picture. Because this is what you are seeing right now. This particular algorithm you see, this is nothing but your linear regression, representation of linear regression. Right, this equation. But what we will do? We will take its output and try to convert this output into a probability, which is always between 0 and 1. So how will we do that? For the same purpose, actually, we have a function here known as sigmoid function. So what we do in case of logistic regression, we take the output of linear regression and pass it to a function known as sigmoid function. Okay. Now, whatever value you will pass to the sigmoid function, doesn't matter what value it is having, positive value, negative value, 0, whatever it is having, it will always give you value between 0 and 1. And this is what we call it as your output. Whatever output you will achieve, this output will represent your probability. Okay, this y hat, if we talk about this y hat, will always between, understand, 0 and 1. So what we do in the logistic regression, take the output of linear regression and pass it to a sigmoid function. Okay, or we can say we took our one x1 x2, assign them weights somewhere x0 x1 theta 1 theta 2. Okay, do summation, and whatever output I am getting, I will pass that output to a sigmoid function. What that sigmoid function will do, the sigmoid function will take your y in and always intermediate and convert it into the values between 0 and 1. This 0 1 represents a probability. Okay, this probability is known as probability of default class. Remember, this is the probability of default class. Always represent the default of cross product. You will say, what is the default class? Understand? Suppose I'm doing spam classification. So your mail maybe have a spam or not a spam. So mail is spam, it will be represented by 1. Not a spam will be represented by 0. Okay, somebody is having tumor or not. Okay, that tumor if have will represented by 1. If tumor does not have, we will represent by 0. So what is the default class here? Default class is the one thing here. Means spam is there, tumor is there. This is your default class. So this y hat always represents the probability of default class. Understand? This y hat always represents the probability of default class. That is your one class. Now see, let me come here to the next slide. Okay, now see everyone, what I said. You take some values like again 1, x1, x2, assign them some weights, theta naught, theta 1, theta 2, pass them to a summer, and after that you pass them to a function known as sigmoid function. Okay, and this sigmoid function will give me the probability. Okay, probability of which class? Default class. Okay, now see everyone, what is the sigmoid function thing? What is the sigmoid? Okay, probability of default class. This value will be always between 0 and 1. The sigmoid function is represented by sigma. Okay, and its value is given by 1 upon 1 plus e to the power. Suppose sigmoid is a function of x, so we can say it is given by 1 plus e to the power minus x. Okay, this is your definition of sigmoid function. 1 upon 1 plus e to the power minus x, and its value will always lie between 0 and 1. If you see this graph, it's very much like this. This is x, this is sigmoid of x. Suppose this is 1, okay, and this is suppose 0.5. Okay, so it's graph very much like this. Something like this. Its graph is like this. This is the sigmoid function. Whatever you value you pass of x, positive, negative, 0, understand its value will always lie between 0 and 1. So with the help of sigmoid, what we have done, a continuous output that we were receiving with the help of y intermediate, we have converted them between 0 and 1, and the 0, 1 is representing the probability of default class. And we can see here, suppose if I go to the Google, sorry, here, and type sigmoid function like this. Okay, and can you see the everyone? Formula is same, 1 upon 1 plus e to the power minus x. And what is the shape of the same? Example this. Can you see everyone? Please check.
Yes, sir.
Right. So what this sigmoid does is sigmoid converts your continuous output into a probability. The probability value will lie between 0 and 1. Okay. So let me go back what we were doing here. Okay. Between 0 and 1. So now how will you classify? We'll classify this, we understand. Okay. It is representing the probability of default class. So we'll say that, okay, probability of default class. So probability is default class. Okay. From this, and this is representing what by sigmoid function. So this let we are saying value we are getting between 0 and 1. This is representing your y hat, predicted value. Sigmoid output or the y hat, but another same thing. Between 0 and 1. So you'll say that if my y hat is greater than or equal to 0.5, okay, I will say that if it is greater than or equal to 0.5, that I will say that it belongs to default class. Okay, and if this y hat is less than 0.5, we'll say that it belongs to the other class, not the default class. Okay, because it represents always the probability of default class. So if value is greater than or equal to 0.5, we say that it belongs to default class. If it is coming less than 0.5, we say that it belongs to other class. And from here also we can say the same thing. Remember, when it will belong to the default class, it will belong to the default class only when x is what? Greater than or equal to 0. Only when x is greater than or equal to 0, you will get your probability to be 0.5 or higher. Okay, so same thing we can represent this way as well. Theta naught plus theta 1x plus theta, so theta 1 x1 plus theta 2 x2 should be greater than or equal to 0. This is the equation. Right now, what is your objective, everyone? You have to tune your theta naught, theta 1 and x2 in such a manner so that you get correct output. That's the only thing that is required. You have to choose theta naught, theta 1 and theta 2 in such a manner. You have to tune them the way we did in the case of our machine learning algorithm, or in case of our linear regression. We also tuned our theta naught, theta 1 and theta 2 again and again so that we get minimum error. This time what do we want? We want the correct classification. So theta naught, theta 1, theta 2 has to be chosen in a manner which gives you correct predictions. Okay, tune them so that they give you correct prediction. So far, everyone, is it clear what is the sigmoid function? How we converted our continuous numeric output into the probability? What this probability is representing? That probability is representing probability of default class. And when what is the condition? When your probability is coming greater than or equal to 0.5, we'll say that belongs to default class. If it is coming less than 5, we'll call it as the other class. Okay, and same thing. Actually, interview they will ask you in a sigmoid function. In case of logistic regression, can you tell me what is the decision boundary? So actually, this is the equation of decision boundary. If somebody asks you what is the decision boundary, just mention this: theta naught plus theta 1 x1 plus theta 2 x2 equals to 0 is exact decision boundary, because it is greater than equal to the boundary we are talking. Boundary is what equals to. So this is the equation of decision boundary to separate your positive class from, or your default class from the non-default class. So far, okay, for everyone, please tell me.
Yes, sir. It's okay.
Okay, now move ahead, everyone. Now move ahead. Okay, now see what will be the loss function for the same. So loss function or the cost function, whatever you call it. Suppose I come here. Okay, so cost function is what? For logistic regression, cost function is minus of log y hat. Y hat is what? Remember, probability of default class. Okay, probability of default class. When actual class is 1 or default class, actual class is 1 or probability or default class, right? And same cost function is minus of log 1 minus y hat when your actual class is 0 class. Okay, actual class is 0 class or non-default class, because default class is takes to be 1. So other class will come to be your non-default class. So when actual class is 1, this is your cost function minus log of y hat. And when actual class is minus log of 1 minus, when actual class is 0, it is minus log 1 minus I. You may choose, sir, why this log has been chosen. It doesn't giving me an idea, giving an intuition, everyone. Just see the graph of log. You will understand everything. Understand the graph of log. Let me come here. Suppose I show you here a graph of minus log x, something like this. Okay, let me come to the all. Can you see a graph here, everyone? Please see. What this graph is? This graph is minus log x, and what it is representing. Understand? In our case, we know that our x, okay, it is what minus log x. So in our case, it has to be plotted like this. Here we will have y hat, and here we will have minus log y hat, right? One and the same thing here, minus log of y hat. But in our case, it will not go beyond because maximum probability we can have is 1. That is the one. Okay. And when I said, remember this minus log of y hat is a loss when your actual class is 1. Understand everyone? Or your default class. Okay. So shape will be what? This will be very much like this. And you may say, sir, how it is the thing? See, simple logic. Y hat represents the probability of default class. And we clearly said that when y hat will be greater than or equal to 0.5, we will say that it belongs to default class or to class 1. Or class 1. Perfect. No problem. See everyone. So what should happen? Okay. So more closer, my y hat moves towards the 1. Right. So there are, I said y hat should be greater than or equal to 0.5. Okay. So it should be greater than 0.5. So if I am 0. Suppose my y hat is coming 1. So is there any confusion, everyone? Or you can say confidently it belongs to default class. Tell me. Right or wrong? You can confidently say because condition is y hat should be greater than 0. Equal to 0.5. Then I will say that my default class is a default class of the class 1. When y is equal to 1, is there any confusion? You will quickly say what? It belongs to the default class only. Right? When my probability start decreasing from 0.1 to 0.9, still it belongs to class 1, but the probability is decreasing, right or wrong? Your cost, what is happening? The chances that it maybe means 90% will belong to the class 1 only, but 10% chances are that it may belong to the other classes, right? Similarly, when I'm moving to the 0.8, okay, so what is happening? Again, very, very simple logic. Again, 80% are chances of belong to the class 1, but now the chances of belonging to the other class is also increasing 20%. When y hat is 0.7, again, it is will belong to the class 1, but again, understand everyone, the probability or the chances of belonging to the class 1 is 70%. Other class is what? 30%, right? Or 0.3. Similarly means when my probability is decreasing, the chances of belonging to the other class is also increasing, right or wrong? Please tell me.
Yes, sir.
Right? So when we say my chances of belonging to the other class is increasing, what is happening? My loss is increasing or my cost is increasing. Okay, my cost function is increasing. That's what I've been shown here. See, if I use this one graph, so the more towards I am moving towards the y hat, means my probability is increasing. My chances of belonging to the class 1 is also increasing. That means my cost should decrease. And my cost should be 0 when I have a 1 probability. That means guaranteed I belong to the default class. Okay, so more my probability increases, there are more chances that I will belong to which class? Default class. Hence my cost will increase. But if my probability decreases, okay, my chances of belonging to the class 1 also decreases. And hence my cost increases. Clear? Now tell me,
Yes, sir.
right? It should be okay. How it does. Similarly, what was the other case we mentioned? Remember? We mentioned that minus log of 1 minus y hat. Minus log of 1 minus y hat. That is 1 minus x. See the graph this time, everyone. What is the graph? Minus log of 1 minus x. So what is that? In our case, again, you will take a y hat here. Okay. Here we will have a minus log of 1 minus x. And it is coming was 1 minus y hat. When your actual class is 0 or the non-default class. Okay. So see everyone. Tell me automatically when my probability will increase, okay, towards the 1. Which class it will belong to? Which are more chances? Which class it will belong to? The default class or the non-default class? If it is coming towards the 1. What represents? Remember what y hat represent? Y hat always represent the probability of default class. Okay. So if probability is increasing towards 1, what will happen? Which are increasing the chances of which class it belongs to, default class or non-default class? It is always the probability of default
Default
class,
class.
right? Default class means the probability of belonging to the default class is increasing, or we can say in opposite, the probability of non-default class is what? Decreasing, right or wrong? When the probability of default class is increasing, we can say probability of non-default class is what? Probability of
Decreasing.
non-default class is decreasing. Or we can say more chances of error are there or not. Because your actual class should be what? The non-default class, zero class. But your probability is saying, no, 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 belong to default class. So what is happening? The more higher the probability is, more should be your cost function. Your cost function should be maximum when your probability is what? 1. When probability is coming 1, what means? This is saying belongs to default class, right? Belong to default class, but actual class is what, everyone? Actual class is a non-default class. And hence, in this case, your cost will be maximum, right? The lesser the probability, the probability decreases. The more your probability decreases, your chances of belonging to non-default class increases. Okay, when the chances of non-default class increases, understand automatically your loss decreases. Right or wrong? Please tell me.
Right, sir.
Okay, this is why we have taken this. Sorry, this one. This is why this equation has been written. Yeah.
Yes,
Right?
sir.
Okay, and we can combine this as well. We can combine this as well like this. My complete cost function is given by, see everyone, because we may have n data points. So I'm mentioning here 1 minus n. Okay, summation I is equal to 1 to n. Okay, because we are finding average cost function, right? So it may be n data points. I'm taking that one. Square bracket yi, where y is what? Your actual class. Remember, probability of actual class. Okay, actual class. This is your actual class, representing actual class. And here I mentioned, sorry, not 1. Come on. Minus log of y hat. Okay, yi. Minus log of yi hat plus 1 minus yi. Again, yi is what? Your actual class, remember? Okay, minus log of 1 minus yi hat. Like this. Let me close this and let me close like this. Something like this. This is my complete expression. Okay, just combine these. I've combined these into one expression and just take an average of the same. You may say, sir, how it is working. Suppose your actual class is 1. Okay, your actual class is 1. So your actual probability will be what, everyone? Yi will be what? When actual class is 1, your yi will be, of course,
One.
1 only, right? So when I put 1 here, so this is fine. What this term will become? 1 minus 1 will be
Zero.
what? 0. So this will be gone. So only thing remaining will be what? 1 upon n summation I is equal to 1 to n. Okay, minus of log yi hat. Can you see, everyone?
Yes, sir.
Right? And when your actual class will be 0, when actual class will be 0, this term will be gone because yi will become 0. It is gone.
Yes.
Right? It will be gone. So 1 minus 0 will be 1. So only thing that you will be getting will be what? Minus log 1 minus y hat. Okay, and this is representing what? Your actual class, and this is your predicted one, probability of predicted class. Okay, your actual class is what? This will have the value either 1, okay, or it will have the value 0. Y1, yi may be 1 or yi may be 0 because two classes are there. Na? So actually it may be 1 or actually it may be 0. So sometime you have to put 1 when actual class is 1, and when it is 0, you will put it to be 0. So yi value will come 1 or yi value will come 0, depending upon which class it belongs to. Clear?
Clear, sir.
Right? And last thing, just 2 minutes or then I'll call it a day. Okay. What I was talking about, remember, normally it does binary classification only. Okay. But it can do one thing. Suppose I have this kind of data set. We have x1 and x2. Okay. Few data points are lying here like this. Okay. Few data points are lying here like this. Okay. And let's say a few data points are lying here like this. Okay, and there are representing three different classes. This is class 1C, This is class 2 and this is class 3. Okay. So my logistic regression can only do binary classification, of course. So what it will do, it will use a methodology of one versus rest or one versus all. Okay, what is that? Okay. How many classes are there? 1, 2, 3. So it will build 3 machine learning models, train 3 machine learning models. Machine learning model 1, machine learning model 2, machine learning model 3. Okay, it will train 3 machine learning models. How it will train 3 machine learning models? One machine learning model will consider that, okay, let this is the default class. This one. C1 is a default class and rest all other are other class. Still doing its binary classification only, right? So what it is doing, it is saying that one class is C1 and rest all are in one class. Rest all are in one class. So two class still, but C1 is one class and rest are in other class. C1 is a default class, rest are in other class. Train my machine learning model 1, done. Now, how will you train your machine learning model 2? It will say that let C2 is one class. Okay, C2 is one class and rest 2 are in one class. Rest remaining are in one class. That's why the nation is what, remember? One versus rest or one versus all. So C2 is your default class, the rest all are in other class, and train your machine learning model to be M2. Right? So M1 will give me the probability belonging to the class 1. M2 will give me the probability belonging to the class 2 because they give the probability of the default class, right? Similarly, third machine learning model will be trained like consider C1, C3 to be the default class and rest all are in one class. Means C1 and C2 are in one class. C3 is the default class and C1 and C2 are the other class. C3 is the default class, C1 and C2 are the other class. So what it will, now my machine learning model 3 will be trained. And what it will give me? It will give me the probability of belonging to the class C3. This is how C3, internally 3 models will be trained. M1, M2 and M3. Now what happens? Suppose you pass a test point. You pass some test point value of x1 and x2 and you want to do the prediction. Tell me which class it belongs to. Okay. So machine learning M1 will give me some probability P1 belonging to which class? C1. M2 will give me the probability P2 belonging to the which class? C2. So all model will be testing. We'll pass this data point to M1, data point to M2, this data point to M3. So M1 will give me the probability of this point belonging to the P1 class, C1. Oh, sorry, C1 class. Probability is P1. M2 will give me the probability of belonging to the C2 class, that is C2. And M3 will give me the probability belonging to the C3 class, which will be P3. Now we will check among these three, which is the highest. Okay, or we'll pick max of P1, P2, P3, whichever is the highest. Suppose P1 is highest, so we'll say it belongs to which class? C1 class. If P2 is highest, we'll say it belongs to which class? C2 class. If P3 is highest, we'll say that belongs to the which class? C3 class. Is it okay, everyone?
Yes, sir.
Right? This is known as one versus rest or one versus all. Internally, it is doing binary classification only two class classification. But how it does internally, one versus rest or one versus all. Okay. So I'll call it a day, everyone. See you tomorrow. We'll implement this thing tomorrow. Okay.
Yes, sir. One more thing.
Uh-huh.
Sir, we are yet to do that R2 implementation with R2 matrix in practical.
R2 or confusion matrix?
R2 that you taught today.
No, it is not a matrix. It's not a matrix. It's an implementation,
Okay.
not a matrix. It's not a matrix. R2 score it is. Okay, it's a score. And we did that. See, we find out the value. Here it is. See, where it is? It is there. We find out the R2 score. It was coming 0.9. If I'm correct, see, this is the one.
Okay. Yes. Yes.
Okay, we did that. It's not a matrix. Just it's not a matrix. It's a metric actually. Okay. Okay. You are saying that matrix. I was considering that matrix. Actually, it's a metric. Okay. It's a metric. And just needs two arguments: y test and y pred. It when we computed this is the value we were achieving, right? See. Okay. Automatically it will do internally. Fine, Hardik. Am I audible, Hardik? I'm not able to hear him. Is he there? Hardik, your voice is not coming.
This meeting is being recorded.
Hardik?
Sorry, sir. I got disconnected.
This was you were talking about, na? R2 score?
Yes, sir.
See, we did that.
Yeah. So there is just one line command about it. So
One line command. Only one line command. Only one line. I thought actually you were talking about confusion matrix. Matrix, I was understanding. You were saying a metric, right?
Yeah.
Okay,
That's
okay,
right.
no issue. Okay, this is a simple command, one line command. You have to just pass test and that will give me the result. That's the only thing that we require. Okay,
Yes, sir.
okay. Bye bye. Take care. Bye.
Thank you, sir. Bye.
Thank you. Bye bye.